Hello and welcome to this lesson about the basic of variable expressions part 2. The learning target for this video is evaluating nonlinear expressions and combining like terms. So first, I want to start by defining like terms. So like terms are terms, or we'll call it terms, with the same variables raised to the same power. And that is what like terms are. So for example, we are looking at something like x and 3x. And when you have like terms, you're able to combine them, and then you do what I like to call finger math with these. So if you have one of something and put one on one hand, you have three and you put three fingers up on the other hand, combine them. How many fingers do you now have? You have 4 of them. Or if you have 3 of them and you take away one of them, how many do you have? You have 2 of them. And so like terms are needed for us to do operations with something. Now, x and 3x are like terms. Let's say a squared and, not a plus, but a squared and then 5a squared. They are also like terms. So likewise, we can do operations with a squared and a. But we can't do anything with these two. These are not like terms. So I'm going to put a little red circle around there. Not like terms. They are different variables, and they're raised to different powers. And so that's where this can get a little bit confusing as well. X squared plus x. That is as far as you can take it. You cannot combine it. We have the same variable, but it's not raised to the same power. And so the analogy I love to use for this is like fruit. So we can say X's are apples, but you have red apples and you have green apples. They're different types. So if we want to get more specific, how many red apples are there versus how many green apples, you can't cross combine them. You can only, focus on that one color. So that's what like terms are. Now let's talk about using this. So combining like terms comes in handy because there'll be times when we'll have expressions or parts of equations where we have something that repeats itself. So let's just say we had 5x plus 4 minus 3x. Here, the x's are like terms. Now, notice how I included the sign, that minus 3x. And so since these are like terms, I can say, all right, well, if I have 5 of something and I'm taking 3 away, how many would I have? I'd have 2 of those x's. And then the 4 comes down because it doesn't have any other like terms, so that's as far as I can take that. Another example would be something like, let's say we have 6x minus 7 plus x plus 5. So now here we have 2 sets of like terms. And what I like to do is either underline them, like, clearly identify one set of like terms. And if you want, you can circle the other. And again, don't forget that minus sign, because that's huge. So 6x, 1x. We combine those. That gives us 7x. Negative 7 plus 5 is minus 2. And now we've combined our like terms together. All right, let's do one more for good measure. Now, let's say we have 2x squared plus 10x minus 4 minus 5x squared plus 3x minus 6. Now here we have a lot of sets of potential like terms. So I'm actually going to use a different color here. We have x squareds. Don't forget the sign. You have our x's. And finally, we have the numbers. And so now it becomes small arithmetic problems. We're looking at 2 and negative 5. Whatever the answer is going to be to that, the x squared is going to be next to it. So that's why I like to call it finger math. It's like you have 2x squareds, you're taking away 5 of them. How many x squareds are left? Well, we'd have negative 3x squared. Then for the yellow ones, the x's, we have 10x and 3x. So we have to add those up, and the result of that will be 13x. And finally, we have our numbers. Minus 4 minus 6. That's minus 10. And that's the final answer right there. Now, some of you are going to be tempted to try to combine these. but they're not like terms, so you can't do that. Let me write that in red. Not like terms. Same variable, but not the same exponent, so they're not like terms. So that's combining like terms. Next, we have evaluating nonlinear expressions. And what this whole nonlinear part means is that we're dealing with exponents. Okay, so for example, let's say we have the problem, and we're going to evaluate, and x is going to equal 5. And we have to evaluate 2x squared plus 1. The process we use for this is no different than evaluating linear expressions. It's just we have to be extra careful when we plug in our value with the exponent. So 2 times 5 squared plus 1. Now here's the thing. Only the x is being squared. So I have to do this part first, 5 squared, then I'm going to times it by 5. If I was supposed to multiply the 2 and 5 together first, it would be like this, 2, or parentheses, 2x squared. But that's not what we have, so we're not going to do that. We're going to go 2 times 5 squared, which is 25, and then we're going to add 1. 2 times 25 is 50, adding 1 is 51. Now, let's borrow that same problem, but let's change our value. Let's say x now equals negative 6. And we're still looking at 2x squared plus 1. So I'm going to substitute negative 6 in for x squared, 2, in parentheses, negative 6 squared plus 1. Now, we're going to do a little aside here. Negative 6 squared. What that means, exponents are shorthand for repeated multiplication. This is negative 6 times negative 6, which is positive 36. So that's what I'm going to put in my parentheses now. 2 times 36 plus 1. Multiply 2 times 36, that's 72. Add 1, we get 73. So we got to be careful because sometimes those negative signs, they might mess with us. We'll do one final example. Let's say we have x squared plus 5x plus 6. And in this one, we're going to let x equal negative 4. So substitute it in, negative 4 squared plus 5 times negative 4 plus 6. So we're still doing the same thing we did earlier where we're using parentheses to substitute. Now it's an order of operations problem. Take care of our exponents. Now remember, negative 4 in parentheses squared is negative 4 times negative 4. The parentheses are being repeated. That's 16. So 16 plus 5 times negative 4 is negative 20 plus 6. Now we have to work left to right with the addition and subtraction. So 16 plus negative 20 is negative 4 plus 6. Add those together, we get positive 2. We box it, we walk away. And so that's the basics of expressions part 2. Sometimes we're going to have like terms where we can combine them. Other times we're going to have nonlinear terms. So here, combining like terms. Here we have nonlinear expressions, and we have to do a little bit of extra work to square something before maybe multiplying it, dividing it, adding and subtracting. So good luck with this, your homework and practice, and let me know if you have any questions.